Okay, we're going to start section 1 today. If you guys notice, we're in section 1 all this week, so we split it up into a few different parts. So today is specifically just talking about what to do with similar polygons. So a similar polygon, they have corresponding angles that are congruent. And then they have corresponding sides that are proportional to each other. So we know congruent means the same, all right? So we know all of our angles are going to be, like in this case, A is congruent to P, B is congruent to Q, C is congruent to R, right? So it gives us this congruent statement. It says, given that triangle ABC is similar to, that little mark means similar to, triangle PQR, write congruent statements for the angles and a statement proportionality for the sides, okay? So we just talked about, we know angle A is congruent to what? Right, which those are marked the same. How else could I know that if I didn't have the picture of the two triangles? Anybody remember? Yeah, in my order up here, let me find this. Right, A is written first, P is written first here, so then those two are the same. Okay, all right, so angle B then has to be congruent to angle Q, right? Both are in the middle, so they're congruent to each other. And then angle C is congruent to angle R. Okay. All right. Then for corresponding sides, a statement of proportionality just says, like, if I take side AB over side PQ, right? So I'm writing those as a fraction, side AB over side PQ. I can set those equal to the other sides, right? So then that would be equal to, what is this side be called here? AC, and what would I put AC over? PR, right? Because they're corresponding sides. So AC over PR. And then again, my last set of sides would be BC over QR. Now, a couple things we need to know. The sides are not congruent. However, the side ratios are equal to each other. So that's the first thing that we need to understand about this is the length of AB is not the same as the length of PQ. We understand that, right? Which you can tell from looking at the picture, okay? The lengths are not the same, but the ratio of the sides are all going to be equal to each other, okay? So we can use those things to help us solve for missing sides, things like that. All right? Okay, one of the things we're going to use quite a bit is called scale factor. Scale factor is just the ratio of corresponding sides, right? So essentially, that's what we wrote up here. We didn't use actual numbers, but when I put one side over the corresponding side, that sets up scale factor. So you can use any of the three sides because they're all equal to each other, correct? So it doesn't matter which side you choose as long as you choose corresponding. Could you put AB over QR? No, because they're not corresponding sides. So as long as you choose AB over PQ, right, or AC over PR, corresponding sides, then you will get that scale factor, okay? All right, so given triangle PRQ is similar to triangle SUT, write congruent statements for the angles that correspond, and then a statement of proportionality for the corresponding sides, and then we'll find scale factor at the end, okay? So let's start with angles because those will be our easy ones first. Now, The one thing I'm going to caution you on when there is a picture is to make sure that they are set up the same, right? So this says PRQ, so PRQ is congruent to SUT. So are these two sitting the same direction? Yes, because sometimes they'll put this triangle here and then they'll rotate this one 90 degrees or 180. So you just need to check that before you start. Make sense? So here we don't, so we can use our picture, which is pretty straightforward. So angle P is congruent to what angle? Angle S. Okay, somebody else tell me another pair that are congruent. What other pair of angles would be congruent to each other here?
Angle R.
Okay.
Congruent to angle U.
Good. Somebody else tell me the last pair. Say it, Austin.
QT.
Okay. Angle Q is congruent to angle T. Okay. Right, now we're going to do our sides. Now, our sides have lengths, correct? We can see a length on each of these sides. So we can use actual numbers instead of naming it like SU, okay? Now, if it helps you, like I'm going to show you the example on this one. I'm not going to make you write this out every time, but we are going to go ahead and put like side PR. And what would PR go over? SU, the corresponding side. Okay, we're going to name them first, and then we'll go fill those in. Again, I'm not going to make you do it every time, but just on this first one so you have that. Okay, all right, and then let's do PQ. What side does PQ correspond to? Yes. Okay, and then our last one, RQ corresponds to UT. Now we're just going to go replace those side links with what they're actually equal to, right? So the distance from P to R is what? 8. So I would put 8 over 12, right? Because 8 corresponds to 12. Okay? And then I'm going to do PQ. PQ is 10 over ST. What was ST? 15. And then RQ, 6 over 9. Okay? Now, can you simplify these fractions? What does 8 over 12 simplify to?
3/4. No. Oh, no.
They're both divisible by 4. Yeah, 2/3. Okay, what about 10 and 15? Both divisible by 5. So that would give me also 2/3. Same thing with 6 over 9. Also 2/3. Okay? Now, here's the thing. Remember we talked about scale factor is the same thing as setting those sides proportional to each other. So what would our scale factor be here? 2/3, yeah. So what that tells you, I'm going to write this over here. Triangle PRQ is 2/3 the size of triangle SUT. Okay? So in all reality, we're just setting angles equal to each other and then writing our corresponding sides as a fraction and simplifying. Okay? Let's look at 2 quick examples on the back and then I'll let you guys go. Okay? All right, so example 1, well actually on both of these, it asks you, are the polygons similar? If so, find the scale factor and write a similarity statement. So the 2 things we need to check is, do they have congruent angles, and then are your sides proportional? Okay, so let's see. So the measure of angle A is equal to what?
35.
True, but what other angle on the other figure? So measure of angle A is equal to the measure of angle X, which is equal to 35 degrees. That way you just don't have to write it more than once. So I'm going to put, well, yeah, that's fine. All right, what about measure of angle B? What angle is it equal to on the other triangle? Measure of angle Y, and those are equal to what degrees? 55. Okay, then lastly, measure of angle C is equal to the measure of angle Z, and what degrees do those have? 90. Okay, so are all of our corresponding angles congruent? Yes. So that part checks. Then I have to go and find corresponding sides. Okay, now this is why I was talking about sometimes it gets a little tricky because they've rotated that second figure. Okay, so what I would do is I would just think about like matching up my sides, or maybe write a similarity like triangle ABC is similar to triangle, so we went 35, 90, 55, so X, Z, Y. That may help you. The other thing you might do is kind of just match up your sides like,
Wouldn't we go X, Y, Z?
well, I went, oh, sorry, I did that backwards on that one. Thank you. Because I went A, B, C, so 35, 55, 90, yes. So the other thing you can do is kind of give your like sides a marking, right? So like if I circle side 15, what side does that correspond to on the big triangle? AC, which would be 24. So I might circle those, okay? Then I might box in 20. What does 20 correspond to? Yeah, 32. And then maybe just underline the last two. Okay. So now I can like easily go through and write my proportional sides. So I'm going to start with AC, 24 over what? 15. Okay. And then let's do 32 over 20. And then 40 over 25. Okay, now all I have to do to make sure that they are proportional is simplify each of those fractions. What can you divide both 24 and 15 by?
3,
Okay, what's 24 divided by 3?
8,
15 divided by 3? 5. Okay. What about 32 and 20? Okay, divide them by 4. We do get 8 over 5. And then what about 40 and 25? Good. So we also get 8 over 5. So yes, they are proportional. So the two polygons are similar, right? As long as those things work for each other. Okay? All right. Okay, obviously example 2 is going to be a little different because it's what type of figure? What is it? What do you notice about all sides? Opposite sides are parallel, so it's a parallelogram, right? Okay, so we kind of already have all the sides filled in. The problem is we don't have all of our angles filled in, so let's do that first here. What do I know is directly across from 80? Directly across 80, right? Because we know opposite angles are congruent, so same thing, I'm going over here and putting 100. Now, how can I find this missing angle down here? What do I know about these two together? They equal 180, so my missing angle has to be 100, and across from it, also 100, okay? Same idea on my second one. I know that these two have to add to 180, so that means my missing angle up here has to be what measure? 80. And then directly across from it, also 80. So, first question's easy to answer. Are corresponding angles congruent? Yes. Okay. Now, on this one, we don't have to set up 4 different fractions because we're going to get 2 of them exactly the same, right? 6 and 16, 6 and 16. So let's just write each of our fractions. Now, here's what you have to be careful about. Does 6 go over 16 or over 24? Over 24, right? Because this one would have to rotate one direction, okay? So we know we have 5 over 16 equal to 6 over 24. Now there's 2 ways that you can do this, right? The first way we've been doing is simplifying our fractions. Can you simplify 5 over 16? No, right? Because the only thing you can divide 5 by is itself. 16 is not divisible by 5. How can you simplify 6 over 24? Divide by 6 and we get 1 over 4. Are those 2 things equal to each other? No. Now, the other thing you could do is you could cross multiply. Anybody have their calculator out? Okay, so we could just cross multiply those things, right? 5 times 24 is going to give you 120. And then 6 times 16, 96. Not equal to each other, so that would work as well. Okay, so either of those 2 methods would be fine. Okay, questions on this? All right.